When you unlock your phone, a whole network of servers kicks into gear, using more energy than some small cities. That one WhatsApp message, it travels thousands of kilometers through undersea cables. And yes, you've probably heard it. Asking ChatGPT a question can use up as much water as a large bottle of mineral water. We keep telling ourselves we are becoming more aware of the environmental cost of our digital lives. But are we really? Let's find out. In 2024, there were over 50 billion devices connected to the internet worldwide. Each one, phones, routers, servers, 5G towers, is part of a vast network that together consumes more energy than the entire aviation industry. Those 5G towers powering our digital lives, they use 2 to 3 times more energy than their 3G and 4G predecessors. The digital world already accounts for 4% of global CO2 emissions. Just 1 hour of HD streaming a day can add up to 1 ton of CO2 in a year. So we have to ask, what's the true energy cost of being constantly connected? And more importantly, is it sustainable? Today we are starting with a case that challenges us to rethink all of this from the ground up. Energy Cool, a Danish company that's revolutionizing how data centers and telecommunications facilities are cooled. Instead of relying on energy-hungry air conditioners, they use outdoor air and smart systems to cool servers, cutting energy use by up to 80%. Less energy, lower emissions, and a big step towards a greener digital world. It's not just innovation, it's a necessity. Hi Henrik, welcome to the podcast.
Thank you.
Let's start with, maybe you can explain us what this project is all about.
Sure. We have developed a solution that cools communication equipment using a very little amount of energy, so little that it can even run on batteries. This makes mobile networks more stable, sustainable, and ready for emergencies and breakdowns.
And why is it so important to keep this equipment cool?
Because data use keeps growing, and that means that it needs more servers closer to users, and the device get hot, and if they are not properly cooled, they can fail. Our solutions cut off up to 40% of the total energy consumption for a technical shelter or site like this.
I presume there's plenty of environmental benefits with your project, right?
When you have a server, you have a backup system, and the server needs cooling, and the backup keep the server running if you have a failure on the power, or if there's a breakdown on the power, you still need to communicate, and especially with the mobile phones. So this we are using low energy to cool the server so it can still run when there is no power. Normally cooling are supplied by the main power. So if the main power make a mistake or fail or is a failure, you don't have the cooling. So you need to cool the server if you have to run it in a breakdown period. So it's a win-win for everyone that bring down the consumption and supported the cooling by the batteries. And then if you have enough batteries and if you have solar panels, what is in some way we have solar panels directly on these technical installations, you can even help the grid starting up again or balancing the grid. So there's a lot of quite good benefits in it.
Henrik, thank you, and it's been a pleasure having you on board today. The global telecommunications system runs on an invisible yet incredibly hungry infrastructure. Millions of mobile antennas, fiber optic networks, undersea cables, and massive data centers. This complex architecture is what keeps us all connected, but it comes with an energy cost most people are unaware of. Welcome to the show, Mila. Thank you for having us.
Thanks to you. Thank you for this opportunity.
Mila, you're in charge of energy procurement in communications infrastructure, right? What type of energy is currently being used in the sector?
We had a total consumption of 1.5 terawatt hours in our towers in Europe. And this electricity, consumption comes mainly it's mainly electricity, and 100% of this electricity this year it's being renewables.
And what are the main technological challenges when it comes to powering telecom facilities?
Our main goal is to reduce our emissions. Our scope 2, that is the electricity we consume, is already 100% renewable. So now we are working on reducing as well our scope 1, that is mainly what I mentioned before, the consumption from hybrid solutions. These are hybrid solutions, and as well, the cars of our employees. And of course as well the scope 3. The scope 3 is the emissions coming from our clients and our supply chain, as well as landlords. So we are working as well making green the electricity coming from our landlords.
And do projects like Energy Cool represent a step in the right direction?
Yeah, of course. This is a project that I find it really interesting because help us to integrate both worlds. The energy world, the energy field, that is my expert field, with the telco sector. Why? Because in telco, the resilience is a must. These batteries, this technology offers us further capacities. Okay, so we can use the batteries for backup, but as well with an extra capacity, we could offer this extra capacity to electricity network. So the idea is that with our batteries, so many distributed and small batteries, aggregating the flexibility that these batteries offer us, and can offer this flexibility for the management of the electrical network. We can help, the telco sector can help the energy sector integrating more and more renewables in the grid. So this also benefits the whole system.
Well, Mila, I have to say that it sounds great. Thank you very much. Most telecommunications infrastructure, antennas, communication hubs, network routers and data centers is powered by the conventional electricity grid, which in many parts of the world is still dominated by non-renewable sources. They rely on public electricity, which still comes mainly from fossil fuels in many countries. Backup diesel generators are also used, highly polluting and costly to operate. But in regions leading the energy transition, renewables are gaining ground. Hybrid systems are now being used to power remote antennas in micro data centers. Hello, Alicia. Welcome and thank you for joining us.
Hello.
Alicia, how important is energy use in the telecommunications sector?
In the telecommunications sector, energy is critical because if you think of it, we need energy to power all the equipment that is needed for telecommunications to work, and also for the infrastructure, for the cooling systems. And in this sense, for instance, Cellnex provides energy to the operators, and is also very important to be energy resilient in case there is a blackout, and telecommunication services still need to continue working despite not having energy.
And day by day, telecom companies are working hard to become more sustainable. What does it really mean to be a net zero company?
We are planning to be net zero, and this is very important for us. What means to be net zero means that you have dramatically reduced your carbon emissions, and you will do this by, for instance, ensuring that you use 100% renewable energy, ensuring that you use electric cars fueled by renewable energy, and ensuring that your suppliers also use renewable energy. And this is a challenge, a huge challenge, because you need to transform all your operations, not only your operations, but also those of your suppliers. And it's a challenge that you cannot achieve alone, that you need to achieve in collaboration with all your stakeholders.
And now thinking about everyday people, what can they do to actually reduce their carbon footprint?
It's small gestures, but that really help. For instance, what we can do is stop buying new devices every year and try to use devices, our mobiles or laptops for longer. We can be more energy efficient, for instance, unplugging our routers if we are not using them. And we can be more efficient in the way we use digital communications. For instance, I hope people are downloading this video and not watching it online on stream, because this is less efficient. Or using, for instance, your Wi-Fi connection instead of the data on your mobile.
I presume being careful of the use of the cloud is also important, right?
Yes, sure. And this is something that I think we can all be blamed for, which means that, every one of us stores information on digital format, thinking that the cloud, it's fluffy and doesn't consume energy, and it's exactly the opposite. The cloud actually, it's very earthy and consumes a lot of energy. So if we avoid, storing so much information that we never use, this is also very, very useful to have less energy consumption. So this is something that we should all do.
I'm taking note on that. That's a very good advice. Thank you so much, Alicia. In the end, staying connected doesn't have to mean disconnecting from the planet. Behind every message, every stream, every call, there's a choice and the power to do things differently. If we imagine a digital world that's smarter, cleaner, and more conscious, then we can help build it. One action at a time, because the future of connectivity is not just about speed, it's about responsibility.
More fascinating stuff. Thanks, Adela. Hey everybody, let's get you hooked up with the latest rapid recap. First, absolute sustainability is a real thing in our minds. It's like retirement, We're working towards it, and who knows, maybe someday, but it's like with the North Star. Just because we can't reach it tonight doesn't mean we can't use it to set our course. That might be the smartest thing I've ever said. Hey, which way's north so I can find it? Point number 2. When it comes to energy consumption, this sector is a hungry, hungry hippo. No, seriously, it would bankrupt an all-you-can-eat buffet if you let it. Which means, point number 3, sustainability is a necessity. And since necessity is the mother of invention, she's busy having kids left and right now. And some of her new creations are already helping telecoms have a more baby-sized carbon footprint. That's all for the Zero Latency Roundup. I gotta scoot. We'll see you next time.